Hello everyone. We are from Team VRBX. I'm Ritesh and we are gathered here to talk about quality assurance. Here are a few concepts which we'll be covering today. So moving on to the first slide, it's a software testing methodologies. So there are two types of software testing methodologies, functional testing and non-functional testing. In functional testing, we'll be testing each function of the software application by providing necessary inputs and comparing with the outputs. Whereas coming to the non-functional testing, it is used it is used to test how good the product is in terms of availability, scalability, etc. So in the next slide, we will be discussing different components. So the first one is unit testing. It is the first step of the functional testing. So we will be testing the application's individual units and if there is any bugs in it, and it will be rectified in the early stages. So next one is integration testing. It comes after the unit testing, where we will be testing individual modules that are successfully tested in unit testing and combined and tested as a group to see if there are any errors when they are combined and used together. So the next one is the system testing. In the system testing, we'll be doing with the system components where we'll be taking inputs from the outside and giving it the necessary outputs. And the next one is the acceptance testing, where we'll be concentrating on the look and feel of the application, which includes the spelling, colors, theme, font, etc. So moving on to the next one, it's non-functional testing, where the first one is performance testing, where we'll be checking the performance of the application when there is a load like many users and a number of data transfers, and check if the application can perform operations in the expected time. So the next one is security testing. Uh, as we can see, the security is a main concern as increasing in the cyber crimes and other few other risks. So security testing is done to check the application's confidentiality, integrity, and authentication. So next one is usability testing. It tests where we check the ease of the application, so how easily it is used by the user. So, and the next one is the compatibility testing. We'll check how compatible the application is with the operating system or the hardware components or the website or other programs. So yeah, and moving on to the next slide, we'll be seeing the software testing life cycle. There are six phases in software testing life cycle. So the first one is the recruitment analysis, requirement analysis. In these, we will be identifying all the functional and non-functional requirements by interacting with stakeholders or the partners as well. So, and after this, we'll be moving to the next step, which is test planning, where we'll be finalizing different tests to be performed and the cost estimations and tools used to test and schedule when the test should be done. Uh, and later, moving on to the next one, it would be test case development. In this phase, we'll be creating, verifying, and reworking the test cases and the test scripts for individual units of the application. Um, and moving on to the next one, in environment setup, we understand the architecture and develop hardware and software condition requirements for environmental setup. So, and moving on to the next one, it's the test execution. Um, in this one, the execution of the code will be done and it is compared to the other output. We'll be sending the input and we'll check the expected output with uh, uh, the output which has come from the input. And moving to the next one, it's test cycle closure, where we will be doing the reports of the bugs which have come in process and the test completion reports and everything in this process, and we'll be closing the cycle. Yep. Thank you. And Next, Vineet Reddy Gale will continue the next slides.
So I'm Vineet, and so as far as testing for verification and validation is concerned, like why do we actually do this? Like, so it's basically for software quality control. This is also known as the VNV model. So VNV, which typically means verification and validation. And so what's the main purpose of VNV model? So it's used to check like whether we are building the right software, and if that's the scenario, then if the software is being built right. So here we have a typical case of where you can see the 4 steps in the diagram, where you'll be having like a problem situation and we need to write a code for this, and then we have to run that. So when we have a problem situation and then we look at a problem statement, so what are we going to do with the specification, and then based on that we'll be writing a code and then we'll be running it. So now, like, we'll be checking like from problem statement to the implementation, like whether if we are like whether we are writing the proper code or not. So that would be done in the verification process. And then as far as the validation is concerned, so like validation is typically the two ends, like the initial problem and then the final output. So whether it's being built right. So that's what verification and validation is all about. So now, as far as the next slide is concerned, it's what are the tools that we use for doing verification and validation. And then we look at the diagram. So the different tools that we use for verification, like style checker, static analysis, proof of correctness, robust analysis. So these are some of the tools which are like out of mainstream. And then like coming to the mainstream, as far as for verification, unit testing, integration testing, and automated testing. And then as far as validation is concerned, out of mainstream, we'll be having like prototyping, goal analysis, etc. And then like the customer acceptance testing and usability testing are some of the examples for validation testing. So coming to the next slide, we have this like I'd not say a concept, but like something called project management BOK, which is the standard terminology for building a product. So in any field, not only in terms of software. So what it means is what like it will be having some terminology and guidelines to build a proper good product. So it's typically based on a process. Like what it means, what it typically says is like a work is accomplished by processes. So these processes are divided into 5 groups, like initializing, planning, executing, monitoring and controlling, and then closing. So each and every group has its own significance. Like initializing, like what are we going to do in the initial steps, like gathering the requirements, etc. Like that's a standard process. And then planning, like how are we going to build a product, and then executing it, monitoring and controlling it, which typically means like the quality assurance, etc. And then closing, like the final touches to the product. So from here, Malay is going to continue. My friend Malay is going to continue from here.
Hi guys, my name is Malay, and today I'm gonna cover agile practices and unified process. So first, agile testing. Agile testing is the software testing that follows the best practices of the agile development. It includes the incremental approach of the testing, and in this type of software testing, features are tested as they are developed. So there are some practices that we're gonna discuss. So first is the continuous testing. Agile teams perform the test regularly to make the certain that product is continually in the progress. Test is done in the conjunction with the development. Continuous feedback. Testers provide the continuous feedback to the team members. Members are regularly receiving the feedbacks regarding the quality rather than requirements. Third one is the involving the whole team. So testers, developers, and business analysts all test the software so we can minimize the error in the software. Fourth one is the quick feedback. In the business team participates in each iteration. Ongoing feedback reduce the time it takes to get the feedback on the development work. Fifth one is the high level software quality. Team tests the software to ensure the code is clean and tight. So though the regularly test of the software issues and vulnerability can be easily detect and fix in the same iteration as they are developed. Sixth one is the less documentation. So team use the reusable checklist. Agile development focus on the current customer needs rather than the comprehensive documented and requirements and instructions. Seventh is the test driven. Testers evaluate the product at the time of the implementation rather than after the implementation, as they do with the traditional testing methods. And the last one is the customer satisfaction. Customers are exposed to their product during the development, so they can adapt and update the requirements according to the development of the progress, and test can be modified and updated the requirements. So next slide is a unified process. So nowadays software becomes are more complex and update very fast, where the developers are using the very old methods like a waterfall and all that, where the unified process is the based on the enlargement and redefine of the system through multiple iterations. And what does it do? Like unified process do, it will provide us the guidance in the order of team activities, integrate, integrates the team works and individual work separately, and also specifies the artifacts and the documentation. And at the last, it also offers the criteria of the monitoring and measuring. So next topic is the V model, and Banu is going to continue with the next
Hi,
topic.
My name is Banu. Before going to shape models, let's talk about system development lifecycle, SDLC, which is a process used by software industry to design, development, and test high-quality softwares. It aims to produce a high-quality software which meets and exceeds customer expectations. A number of different SDLC methodologies are used today, and V-model is one of them, which is also known as verification and validation model, which is developed from a waterfall model and is characterized by a corresponding testing phase from each development stage. This model is useful when there are no unknown requirements. Instead of moving down in a linear way, the process steps are bent upwards after the coding phase, which forms a typical V shape. This means that for every single phase in the development cycle, there is directly associated test phase. That's the specialty. This is a highly disciplined model, and the next phase starts only after completion of the previous phase. The advantages of V model methods is that it is very easy to understand and apply. The simplicity of this model also makes it easier to manage, as the disadvantages as that this model is not flexible to changes, as like a previous waterfall model as it's developed from. While coming to the software requirement specifications, that's gonna be my next slide. Software requirement specifications. It is a description of a, that's going to be a next slide. Yep. Software requirement specifications is a description of a software system which is to be developed, and is also sometimes called as stakeholder requirement specification. It gives us a clear picture or a path of functional and non-functional requirements, and establishes an agreement between customers and suppliers or the developers about how a software project should be functioned. A typical SRH, stakeholder requirement specifications, include a purpose, an overall description, and a specific requirements. A good software requirement specification defines how software system will interact with all modules, with all hardware, and communicate with other programs and human user interactions with wide range of real life scenarios. This establishes an agreement between customers and suppliers or the developers. It is written by technical writers or system architects or developers at times. Well, that's it for today. Yeah, and the references we taken are kept in another slide. Thank you so much.